All right, let's solve problem 200, number of islands. So given an m by n 2D binary grid, which represents a map of ones and zeros where ones denote land and zeros denote water, return the number of islands. So an island is surrounded by water and is formed by connecting adjacent land horizontally or vertically. So you may assume all four edges of the grid are all surrounded by water. So how do we approach this problem? Well, a island is composed of a lot of neighboring ones. So for example, this is an island, so is a standalone one, so is this. You get the idea. So to do this, it's just going to be a very simple BFS. We're going to traverse basically every node that's a 1. So the pseudocode is that we're going to iterate for every row and for every column. If the current element, right, is equal to 1, that means that we are on an island, and there has to be at least, like, if we have a res counter, at least one more. We have to increment the res counter. Like, there's at least one island here, but we don't want to overcount, right? Because if this is right next to this one, well, these two are part of the same island. So how do we do that? Well, we're going to keep track of a visited array that says, have we visited, a given element in the grid? And once we have one here and, right, it's not visited, then we can come here and perform BFS. And we traverse to the next node in the 4 cardinal directions if and only if the neighbor is also a 1. Once we traverse it, we mark it as visited so that we don't visit it again. And we count it as part of the one BFS iteration so that it counts as just one increment of the res value. So we don't, over increment and over count islands. And it might sound a bit complicated, but once you see it in code, it will be very easy. So we can start programming this up. All right, so as we said, we're going to need to know the number of rows and columns of the grid. So rows and cols is equal to the length of the grid, comma, the length of the grid of 0. So that gives the rows and columns of grid. Now we need to have a visited array, a 2D array that indicates if the current element in the grid has been visited or not. So that's false initially, for underscore in range of cols, and then for underscore in range of rows. This declares a 2D grid that's the same size as this grid, but it just indicates whether or not every element has been visited. Now we're going to iterate for R in range of rows, for C in range of columns. If in the current element, we'll just call it grid of RC. If this element is equal to 1 and it has not been visited, so not visited of RC, then we can perform BFS on this current grid element at R, C, right? And once we're done, we're going to have an islands counter to be 0, and islands is going to get incremented by 1. And after all this is done, we have checked every single element in the graph, or rather in the grid. We can just return islands, indicating how many islands there are. So now all that's left is to implement the BFS algorithm. So that's going to be very simple. So def BFS is going to take in a row and a column. So once we have passed in a row and column, we have to check first if the row and column is valid. So if R is less than 0, or R is greater than equal to rows, or C is less than 0, or C is greater than equal to cols, or we have already visited this node, RC, then just return, because that's not a valid position in the grid to check. Otherwise, if we pass this if statement, we have a valid position. So visited at RC is going to get marked to true. And what we're going to do now is we're going to call BFS on the 4 cardinal directions. So R plus 1, comma C, BFS R minus 1, comma C, BFS R and C plus 1, and BFS R of C minus 1. And we need to, and that should be it. So we call out everything, and it should not return anything. All this is really doing is just updating the visited 2D array so that we don't check it again, and yeah. So we should only call this, right, if, or actually we could just add another statement here, or the current grid at RC is not equal to 1, right? Otherwise, right, we don't want to count zeros into the thing. So If it's not 1, then it accounts for that. We don't have to put if statements to see if r plus 1c is actually like, a island position. So now that should be correct. So the logic here looks sound. So we can just run it and see what happens. And it passes, so we can submit. And there we go. It passes everything.